Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 2.5, which is going to deal with creating and solving compound inequalities. Now, a few things before we jump into our lesson and explaining stuff today. Section 2.5 is the end of Module 2. So what that typically means is to be expecting a quiz upcoming. And also know that because this is the end of Module 2, Module 2 is also the end of our first unit, so we have made it through the end of our first unit after our lesson for today. So bravo, good job. We are making our way through this bit by bit. Alright, so creating and solving compound inequalities. So it's going to be similar to what we talked about yesterday with inequalities in terms of less than, greater than, less than or equal to, or greater than or equal to. It's just today we're going to be talking about compound inequalities. So we're going to talk about and statements or statements and how we go through and solve those for today. So with that said, let's go ahead and get into our last section for the module and for the unit. Our first learning goal is you will be able to solve a compound inequality and graph the solution set. So graphs are going to look a little different than just normal inequalities where you just have an open or closed dot and then a line going left or right. Today we're either going to connect two dots or they're going to go in opposite directions. So with that said, before we kind of jump into solving stuff, let's kind of talk about a few things first. Alright, so our first thing here, and let's not do this all at once actually, but a compound statement is formed by combining two or more simple statements. A compound statement can be true or false. A compound statement involving and is true when both simple statements are true, and a compound statement involving or is true when either one statement or both are true. So today we're going to talk about and or statements. And we're going to start with and statements first when we go through and do our problems today. So let's talk about what an and statement is going to look like. So let's move this up so we have a little less wording to look at. All right, so combining two or more simple inequalities forms a compound inequality. The graph of a compound inequality involving and is the intersection or the overlapping region for those two parts. So there's a couple ways that we can go through and have compound inequalities. Okay, we can write it as x is greater than 2 and x is less than 6. So you can have some problems where they just go through and have the word and in it. Or the other way, or the most common way that we are going to take a look at it for today, is we could say 2 is less than x, which is less than 6. So if it's fully connected, which this is going to be how we see it most of our time, so 2 is less than x and less than 6, or we could say 2 is less than or equal to x and less than or equal to 6. Now, when we go through and graph and statements, okay, so we have 2 and 6, so that means that's where our endpoints on our graph are going to be. And because we have two numbers and two inequalities, you're going to have two different dots instead of just one dot like a normal inequality. And because we are talking about and statements, anytime you have and in the problem or your whole statement is connected like this, you connect your two dots. Now, just like normal inequalities, if there's no equal to sign on the bottom, your dots are open. There is an equal to sign on the bottom, your dots are closed. I am just going to make a little bit of a key right here so we can reference. So whether it's less than or greater than, okay, we're going to have an open dot. And then if it's less than or equal to or greater than or equal to, it's a closed dot. So anytime that you have the equal to on the bottom, it's closed. Anytime that you don't, it's considered an open dot. Now, example 1 is going to have us go through and solve different compound inequalities. And I'm going to show you a few different scenarios for what those look like today. All right, so example 1a is going to be 4 is less than or equal to x plus 2, which is less than or equal to 8. Now, to solve compound inequalities, how we are going to do this is we are going to take a look at the inside or the middle of the inequalities for the and statements. So whenever you have a complete statement like this, okay, you're just going to focus on the inside part of your inequalities. So here we have x plus 2. So what would we normally do to figure out what the value of x is? If I have x plus 2, I have to do the inverse, which would be subtracting, because the opposite of adding is subtracting. That means we need to subtract 2 away from this middle part. So if I'm solving for x, we subtract by 2. Now, normally I would say to both sides of the equal sign or the inequality sign. But we have two different inequalities and we have two different sets of sides. When you have an and statement, okay, you're going to do it to all three parts. Okay, if it kind of helps to keep you in track, you can draw lines through like you could with equal signs. Okay, if I'm subtracting 2 from here, I need to subtract 2 from here and from here. If it helps you keep focus, you can draw lines through where the inequality signs are, so you know that you need to do it to each part. So I need to do it to the front, the middle, and the back, or left, middle, right. So if I subtract 2 from all of these parts, okay, 4 minus 2 is going to give me 2. The 2's cancel in the middle, so I get less than or equal to x. And then 8 minus 2 is going to be 6. And then we get less than or equal to. So I now have 2 is less than or equal to x and less than or equal to 6. So that is my solved compound and inequality. To graph this, okay, your graphs on my.hrw.com are going to be a little bit more complex or on a quiz. I'm going to kind of do a more simple. So we're going to go through draw our number line. My two endpoints are 2 and 6. If we look at 2, it has a less than or equal to sign next to it, which means that this is going to be a closed dot, like we see here, and then less than or equal to next to 6, so another closed dot. Because this is one whole statement considered an and statement, that means all we need to do is just go through and connect the two dots, and that is our graph for this problem. All right, so that is how we go through and solve compound inequalities that are and statements, where we just either add or subtract. For part B, we'd follow the same format. It's just the fact that we're subtracting 3 instead of adding 2. So the opposite in this case would be going through and adding 3 to both sides, or to all three sides, sorry. So if I draw my lines, because it's minus 3, we have to do plus 3. So when I go through and add 3 to all three parts, negative 2 plus 3 is 1. It's less than x, because the 3's cancel out. And then 5 plus 3 is going to give me 8. So we end up with 1 is less than x and less than 8. Okay, if we go through and draw our graph, again, my endpoints need to be at 1 and 8, because those are my endpoints here and here. It's a less than and a less than, there's no equal to, so they're open dots. Because we're talking about an and statement, your dots need to connect. So you're going to connect your dots when you have one whole statement, or it's considered an and statement. Okay, some of you may be wondering, okay, how do I know when it's an and or an or statement? When we get to the back side, or example 2, you will see an or statement, and you will see an example of it, And it's very easy to see what that's going to look like, because it legitimately has the word or in it every single time. So whenever you see one whole thing connected, it's an and statement. All right, the rest of example 1 is kind of two-part solving to go through and do these. So I'm going to take a look at C and D just to kind of give us a view and practice, and because it's more than just going through and doing one step. So let's go through and do that here. So for C, we have -5 is less than or equal to 2x plus 3, which is less than 9. So I'm going to go through and just draw lines through the inequality to keep us kind of straight here. So I have 2x plus 3. To solve 2x plus 3, okay, I have to undo addition and I have to undo multiplication. Okay, I need to undo the addition first. So the inverse of addition, or the opposite of addition, is subtraction. So we're going to subtract 3 to all three parts. So -5 minus 3 is -8. So we have -8 is less than or equal to, 3's cancel out, we get 2x. 9 minus 3 is going to give us 6. So I now have -8 is less than or equal to 2x, which is less than 6. Forgot to bring down that less than sign. Because I now have a 2x, okay? What that represents is 2 times x. So I need to divide by 2, and that means I need to divide 2 to all three parts. So -8 divided by 2 is -4. The 2's cancel out in the middle, and then 6 divided by 2 is going to give me 3. So I now have -4 is less than or equal to x, which is less than 3, and that is my final answer for that problem. Now, if I'm going through and graphing this, okay, I have endpoints at -4 and 3. Because at -4, it's a less than or equal to, that's a closed dot. And next to 3 is a less than sign, so it means it's an open dot. And then we just connect them because it is an and statement. All right, D is going to follow the exact same format that we just did here, just different numbers. So if we look at D, we have -10 is less than 3x plus 2, which is less than or equal to 8. So if we're going through and solving this, again, we're going to look at the middle part. So I have 3x plus 2. So what is happening to x? It's being added by 2, and it's being multiplied by 3. So that means I need to subtract by 2 and divide by 3 to go through and solve. And our first step is always to add or subtract. So we're going to subtract by 2. -10 minus 2 gives us a -12. 2's cancel out, so we get 3x. Less than or equal to 8 minus 2 is going to give us 6. And then having 3x means I need to go through and divide by 3 to all three parts. And then when I divide by 3, -12 divided by 3 is -4. If I go through and divide by 3, they cancel out. So we get x. 6 divided by 3 is going to give me 2. So we get -4 is less than x and less than or equal to 2. And my graph, again, my endpoints are at -4 and 2. Open dot, close dot, and then connect. And that is how you go through and solve compound inequalities for and statements. So that is half of our solving for compound inequalities. The other half is going to deal with the or statements for inequalities. So again, compound is going to be when it's fully connected, and whatever you do, you need to do to all three parts. So I need to subtract or add to all three parts, and then you need to go through and divide to all three parts to get your inequality final answer. Alright, so those are and statements. Next, let's take a look at or statements. And some of you may be wondering, how do I decipher whether something is an or statement or not? Well, the beauty of or statements is they legitimately have the word or in the statement. So the graph of a compound inequality involving or is the union or the combined region of the simple inequality graphs. So when we look at or statements, okay, an example would be like x is less than 2 or x is greater than 6. Now, with and statements, you would have your two dots and then you would connect them. Or statements, we're going to have our two dots and you're going to go in opposite directions. So whenever you see and or one whole statement, you connect. Whenever you see the word or, you draw your arrows going in opposite directions. So these do not connect, yet they go in opposite directions. And then all this just shows is that open and then close dots. So let's go through and talk about how to solve or statements. So example 2 again asks us to solve compound inequalities and graph the solutions. Now if we look at example 2a, we have negative 4 plus x is greater than 1, or negative 4 plus x is less than negative 3. Now when you go through and solve or statements, okay, I'm going to kind of draw a little squiggly line through or. When you deal with or statements, you don't do the same thing to every single part. Okay, what I would suggest is either you take a piece of paper or a pencil, whatever it is, but we're going to ignore the right side for right now. So we're going to kind of split this in part, and we're just going to take a look at the left inequality, or the left part of our statement. So we have negative 4 plus x is greater than 1. So we need to go through and set this up. So to solve this, okay, just ask yourself normally what you would do to solve for x. So I have a negative 4 plus x, okay. Because this is addition, I need to subtract. So I would subtract a negative 4. Or the other way, because this is a negative, that means I can go through and add 4 to both sides of the inequality. So when I add 4 to both sides of the inequality, it cancels out on the left and I get x. And then on the right side of the inequality, 1 plus 4 is 5. So I end up with x is greater than 5. Now again, you want to keep these separate because we're dealing with an or statement. So that is the first half of my work for today. For this problem, I should say. So I have x is greater than 5, or now is when we move to the right side. So I'm going to go through and cover up the left side, so we can kind of ignore that. So if we go through and cover up the left, on the right side I have negative 4 plus x is less than negative 3. So we need to go through and solve this. So because this is a minus 4, we need to add 4 to both sides of the inequality. So the 4's cancel out. So I get x, and then this is less than, and then we're going to have negative 3 plus 4, which is going to give us 1. So once I have done that, that is going to be my inequality for this problem. So I'm going to, because 1 is the smaller number, I'm actually going to write this as x is less than 1, or x is greater than 5. Most times you're not going to have to go through and switch it, so I'll show you one where you don't have to. So I have x is less than 1 or x is greater than 5. To go through and graph this problem, okay, we're going to have our numbers at 1 and at 5. At 1 it is an open dot, and at 5 it is also an open dot. The and statements we would connect. Because we have or in our problem, we're going to draw our arrows going in opposite directions. So whenever the two dots don't connect, that's considered an or statement. Or whenever you see the word or, you have to draw your arrows going in opposite directions. All right, part B is going to be very similar to part A. I am going to leave that one for you guys to go through and do. I do want to take a look, though, at parts C and D, because they are a little bit different than what we just talked about, but nothing too intensive. So if we look at C, we have 2x is less than or equal to 6, or 3x is greater than 12. So what I suggest, again, is we're going to go through and cover up the right side first. So I have 2x is less than or equal to 6. So if I were to go through and normally solve this type of problem, okay, you need to ask yourself, what would I do to solve for x? Because this is a 2x, it means 2 times x. So I have to do the opposite, which is divide by 2. So to undo that 2, or get rid of it, we divide by 2, so we get x on the left side of the inequality, less than or equal to, and then 6 divided by 2, it's going to give me 3. So the left part of my compound or inequality is x is less than or equal to 3. So I have this completely solved for x. Now we need to focus on the right. So I have 3x is greater than 12. 3x implies 3 times x. So to undo multiplication, I have to divide. So we're going to divide 3 to both sides. So we get rid of the 3 on the left. And then 12 divided by 3 is going to give us 4. So we're going to have x is greater than 4. This is completely solved for x, so we're good there. And all I have to do is just combine them by putting in the word or. So my statement is x is less than or equal to 3, or x is greater than 4. Now, to go through and graph this, okay, we're going to go through and plot our endpoints first. So this is a less than or equal to sign next to 3, so that means it needs to be a closed dot. This is a greater than sign next to 4, so it's an open dot. And because I have the word or, that means I need to draw my arrows going in opposite directions. And my graph would look just like that. All right, lastly, I do want to take a look at D, because D is not going to involve just one step. For this. All right, so for D, we have 4x minus 1 is less than 15, or 8x is greater than or equal to 48. So let's go ahead and solve this. Again, we're going to cover up the right side, and we're just going to solve the left side first. So when I go through and do that, we have 4x minus 1 is less than 15. So I need to go through and solve for x. Okay, 4x minus 1. That means I need to go through and add 1 to both sides first. So when I add 1 to both sides, we get 4x on the left. and then we get 16 on the right. So then having 4x is less than 16 means I need to go through and divide by 4. So they cancel out. And then we get x is less than 16 divided by 4 is going to give us 4. All right, we have solved completely for x, so we're going to move on to the right side. On the right side, I have 8x is greater than or equal to 48. So to go through and solve this, we're going to go through and divide 8 to both sides. So then that cancels out the 8 on the left. So I get x, and then greater than or equal to 48 divided by 8 is going to give us 6. So this is completely solved for x on the right because I have x is greater than or equal to 6. Therefore, I have finished my solving for this problem. So we're going to add an or. We're going to bring down this x is greater than or equal to 6. That is my final answer for the compound OR inequality. And then to just graph it, we have our endpoints at 4 and 6. It's open at 4, closed at 6. And then you draw your arrows going in opposite directions. All right, so that is how we're going to go through and solve compound inequalities for today. We've taken a look at AND statements and OR statements, how you solve them, and then how you graph them. Now, before I wrap up for today, there are a couple of different situations that I want to take a look at that will be helpful for you for a homework or quiz. Example 3 is going to ask you to write the compound inequality based off the graph shown. Now, if we look at A, okay, a few things we need to take a look at. Okay, we need to identify our endpoint numbers, which in this case is -4 and 2. Then the other part, because my arrows or my lines go in opposite directions, because they do not connect, that means this is an OR statement. Okay, just like B, my two endpoints at 0 and 6, these connect, so this would be an AND statement. Now, to go through and write these for example 3A, I would definitely use this as a reference or go back to my completed notes while you're doing the homework for guidance and just try to match what I have done. So if I go through and write this, okay, it's x is less than, there's no equal to sign because it's an open dot, and then it's -4. We're going to bring in the word OR, and then it's x greater than, and then it is going to involve an equal to sign because it's a closed dot, and then 2. So my statement would be x is less than -4 or x is greater than or equal to 2. So let's double check my components. It's an OR statement, so my arrows need to go in opposite directions, which they do. I need to have an open dot at -4 and a closed dot at 2, and I am all good to go for that. All right, if we take a look at B, this is an AND statement. So x is going to be in the middle. So we're going to have our less than signs for both parts. At 0, this needs to be a closed dot. So that means this needs to involve an equal to. At 6, it needs to be an open dot. So that means it just needs to be a less than sign. So then we're going to get 0 is less than or equal to x and less than 6. And then that is your answer for that problem. All right, one last problem, and then I promise I am done for section 2.5. Example 4 is going to ask us to write a compound inequality and graph the situation. I'm not going to worry about graphing. You should feel fairly comfortable with it by now. But our problem talks about the recommended pH level for a swimming pool water is between 7.2 and 7.6 inclusive. Because this word inclusive, the word inclusive is going to imply an and statement, and it needs to be an equal to. Okay, the and comes from there. The inclusive is going to imply that we need to have it as an and that it's equal to, meaning I need to have it as less than or equal to for my statement. So we're just going to take 7.2 is less than or equal to x, which is less than or equal to 7.6. Inclusive implies that I can have it be 7.2 or 7.6, so I need to have the equal to sign for there. And that is our story problem for our notes today. Alright, so with that said, that is your lesson for section 2.5. Again, 2.5 is the end of Module 2, so keep in mind that means a quiz is upcoming. And again, because we are at the end of Module 2 is also the end of Unit 1. So we have made it through our first unit in Algebra 1A. So props to that, congratulations to you. You're doing great so far. Just keep up the great work. So, with that said, that is all for our video today on and or inequality statements. If you have any questions, next time you see me, just let me know. Or shoot me an email and I'll be more than happy to answer. I hope this has been helpful. And that is all I have for you guys today. So thank you for listening and have a great day. All right, bye.